Hi guys, welcome back to Mathematics for Engineering 3, which is about ordinary differential equations. Today we are going to be talking about uh, some ODEs, which are called exact equations. So first, we're gonna study what exact equations are, and then we're gonna look at how to solve them. Okay? Okay guys, let's look at the definition. We are looking at the first order ODE, this one, m dx plus n dy. And this is called an exact equation if there exists a function f such that df by dx is m and df by dy is n. Okay, so again, this ordinary differential equation is called an exact equation if there is a function f such that df by dx equals this and df by dy is n. Okay, but this is just a definition. So right now, if anybody asks you what exact equation is, so you just say that it's just an ordinary differential equation such that there exists a function f that df by dx is n and df by dy is n. This is a partial derivative. Okay, so the theorem. Okay, for the theorem, they say that if m and n and dm by dx, dn by dy are continuous on any points on D, is a rectangle. This equation is an exact equation if and only if dm by dy equals dn by dx. Okay. So instead of trying to find a function f so that df by dx is m and df by dy is n, and then you conclude that this ODE is an exact equation, what you can do is just that you check whether or not dm by dy equals dn by dx, and if they are equal, you have that the equation here is in an exact equation. Okay, make sense? Oops, sorry, I just changed this a bit. This is the m by dy and the n by dx. Sorry, my bad. Okay, and the function f here is called a potential function. Okay, so let's look at some example. Let's look at this one. Show that this equation is an exact equation. So first we let m xy be 3x xy minus 2, right? And n of xy is x cubed plus 2y. So in that case, we want to check that is an exact equation, isn't it? So what we need to do is that we need to check whether or not dm by dy equals dn by dx. Okay, so if I get back here, I am going to compute dm by dy. So what is dm by dy? So you find the derivative of m with respect to y. So guys, I'm not sure if you remember the partial derivative, but when you find the derivative of m by y, you think of some other variables, for example x, as a constant. Okay, you look at this x here as constant. Okay, so you treat it as a constant. So to find the derivative of this, is, can I write it like that? 3x squared y minus 6x. I just write like that, so that it's easier to find the derivative. So this, it's just a constant, right? So if you take the derivative by y, this is just 3x squared, and the derivative of this is just 0 because it's just a constant. If you take the derivative by y, x is just a constant. And similarly here, if you want to find the derivative of n by x, so you think of y as a constant. So the y here, you just see it as a constant. So the derivative of 3x is 3x squared, isn't it? Right? We find the derivative of n by x, so it's 3x squared plus 0, right? Because 2y is a constant, right? We take the derivative by x, so 2y is a constant. So we have that dm by dy equals dn by dx. Then we have that this equation star is an exact equation. Make sense? Make sense? And that's it. That's the end. But if you want to interpret it, you have that. It means that there is a function f such that df by dx is m and df by dy is n. Right? From the definition. Okay? Okay? But, you know, in exam, if they ask you to do this, you don't need to write this. Okay, this is just my explanation. Okay? I'm trying to relate between the theorem and the definition. Okay, let's, to make it clearer, let's look at another example. Another example would be show that this equation is an exact equation. So it's the same thing. It just looks a bit more scary, but it's the same thing. So here is 2x squared minus x e to the x y squared plus y cos x minus e to the x y squared, right? And n is can I put the minus sign in there, right, to make it easier? So what I have for n is minus 2xy e to the x minus, plus psi x minus y cubed, and that's n nxt, right? I just push the minus sign in the parentheses. Okay, this is equal 0 though. Sorry, might not be able. Let me push it a bit. I just can see it. Okay, so it equals 0. Then if we want to show that it's an exact equation, what we need to do is to find the derivative of m by y, right? Derivative of m by y, as we did here. Make sense? Make sense? And then we're gonna show that the m by dy is the same as the n by dx. So, in that case, we have that the m by dy is what? Is here constant, isn't it? Because don't forget, we take the derivative by y, so 2x squared is a constant. So what we have here is minus 2x e to the xy, right? Because we have y squared here, we push 2 here, and then we have y to the power of 1. Okay, and then we have plus cos x, don't forget guys, this is just a constant. So the derivative of constant times y is a constant. And then the last term is 2e to the xy. And that is dm by dy. And then we need to find dn by dx. And is, you need to look at the function, the y as a constant. So here I'm gonna manipulate, I'm gonna rearrange it a little bit to make it a lot, to make it a bit easier to look at. So here it's going to be 2y x e to the x plus psi x minus y cubed. Okay, so here I take the derivative of this term, right? So I'm gonna look at these guys separately. I'm gonna look at the green and the yellow, and front and back, right? F and G. The FG is FDG plus GDF, right? The derivative of the multiplication of functions. So here what we have is minus 2yx, and the derivative of e to the x is actually e to the x plus e to the x, and the derivative of things in the green color is minus 2y, and the derivative of psi is actually just cos x, right? And the derivative of y cubed is 0 because we take the derivative by x, so y is a constant, so here it's just 0. So I'll just rearrange it a little bit. So what I have here is minus 2x e to the xy plus cos x minus 2 e to the xy, right? I just push this term here, and then I push this term over here. Okay, and then you can see that they are exactly the same, right? And when they are exactly the same, it means that dm by dy is the same as dn by dx, which means that the equation star here is exact equation. Make sense? Okay, so guys, right now we know what exact equation is, right? And we can prove, if the equation is an exact equation, right, by using this theorem. So now the remaining question is that how to solve the exact equations, right? We know if the equations are exact or if they aren't, right? But if they really are exact equations, so how do we solve them? That's the question. So I'll take you to look at the idea first. Okay, we'll look at the idea first. First, let's consider an exact equation. So given this equation, and I assume that this is exact, okay, which means that there exists an f such that df by dx is m of xy, right? And df by dy is n of xy. So in that case, I can substitute m by df by dx, right? This guy by df by dx, and n here by df by dy, right? And this is what I have, right? I substitute m by df by dx and n here by df by dy. And guys, if you remember from calculus, right, we know that here we know that df is actually df by dx plus df by dy. If you remember that, right? It's called total derivative, right? So df is basically df by dx plus df by dy. In that case, if we have that, this is 0, which means that df is the same as this guy, right? Is 0. So this is what we have. We have that df is 0. df is 0. And f is a function. If the its differential is 0, it means that f is just a constant. F is just a constant. Make sense? C is a constant. So if the derivative, the differential of f, right, here is 0, it means that f must be a constant. Otherwise, it can't be 0. Make sense? Make sense? So, just to sum it up, if the equation is exact, right, we can find an f such that df is 0, which means that f is actually the solution, right? So the solution is in this form. So what we need to do is that if we can find f, we can get the solution. Okay, I know it may be confusing at this point, but once you look at exercises, it will be cleared up. It will be cleared up. Okay. So we have to, but how can we find f? How can we find the f? We have two approaches. The first one is the direct method, and the other one is called the observation method. So I'm going to look at the direct method first. Okay. To find the function f with the direct method. So let's begin by consider this function, which is exact. So if it's exact, you have two choices. I'll tell you later which choice you should use. It depends on the question. Okay, but for now, let's say that you have two choices. The first choice is to begin with m. So if you begin with m, but m is actually df by dx, right? Because it's exact equation, it means that there is f, back to the previous slide, there is f such that df by dx is m and df by dy is n. Okay, so if we begin with df by dx is m, then we integrate this guy with respect to f, which means that we're gonna have f, right? F of xy equals the integration of mxt dx. Make sense? Basically, we integrate this equation by x with respect to x. But guys, usually when you do the integration, you have plus c, right? You have plus c plus a constant, right? But that is the integration when you have only one variable. But here, as you can see, it's a partial derivative. So when you integrate, it's a partial integration. So you need to have a constant term. But the constant term is a function of y. Why? Because when you take the derivative of f by x, you look at y as a constant. Remember? When we take derivative of f by x, y is seen as a constant. So when we do the integration, when we integrate f with respect to f, y is a constant as well. So instead of plus c, we plus a function of y. Makes sense? Because right now we are in the function of two variables. Makes sense? I hope it's not too hard, okay? If you get, if you don't understand this, just let me know. But try to look at the exercises first, and then we'll see it will be cleared up. And after that, I differentiate f by y. So what I have is df by dy equals, and I need to differentiate this guy, is mxy, sorry, mxy, not mx, mxy dx plus g prime y. And then we compare df by dy. We have df by dy, which looks like this, right? And then we compare this with the n, because because it's an exact equation, so we know that n is df by dy. So we compare these two guys, and when we compare the two guys, we gonna get gy, and when we get gy, we get fxy as well. Okay, just think of it as a a general idea. It will be clear when we look at exercises. Another choice is when you begin with dy by df by dx, df by dy equals n. Okay, and in that case you integrate with respect to y first, so you will have f xy equals integration of n xy dy plus h of x. Again, when you integrate with respect to y, it means that the constant term is a function of x, right? Because when you take the partial derivative by y, you look at x as a constant. So when you do the integration by y, the constant is function of x. Make sense? And then you do the same thing. You differentiate f by x. Then you just differentiate the whole equation by x of this guy plus h prime. And then you compare this guy, this df by dx with m, because m is df by dx as well. So once you compare that, you're gonna get h, and when you get h, you're gonna get f, which is the solution. Okay guys, before we go to exercises, let me sum it up. When the equation is an exact equation, we know that there exists a function f, so that df by dx is m and df by dy is n, right? And if we substitute it there, right, if we substitute the m and n by df by dx and df by dy respectively, we have that this is 0, but this guy is actually df. Okay, so we have that df is actually 0, and if df is 0, it means that f is a constant, and this is actually the solution. Okay, this is actually the solution. F is C is actually a solution. Okay, so but the remaining problem is that how to find f. Okay, that's the remaining question, how to find f. So there are two choices. First there are two methods, but I'm gonna talk about the first method first, which is the direct method. And for the direct method, there are two choices that you can do. First, you can begin with df by dx equals m, and after that you integrate df by dx with respect to x. in that case, you will have fx. But you have gy as well, right? So in order to know gy, you take the derivative of f by y, and then you get this guy. And you compare this with n xy, right? Because it's exact equation. So nxy is df by dy. So once you compare that, you will get gy, and that's it. You get f equals c is a solution. And for the other case, you can begin with df by dy equals n. And then you do, the same process: integrate, differentiate, and compare. There are three steps: integrate, differentiate, and compare. Okay, integrate, differentiate, and compare. Okay, let's look at the example. Okay, guys. For this example, we see that this equation is an exact equation. Why? Because we proved that in the previous slide, right? This one. We have proved that it's an exact equation. It's the same equation, okay? So I'm not gonna prove it again. But in exam, if you haven't proved it yet, you need to show first that it's an exact equation by showing that dm by dy equals dn by dx. Okay? But right now we know that it's an exact equation. So in that case, I'm gonna begin with this approach, this choice, which is df by dx equals m. So I'm gonna use the choice A. df by dx equals m. But what is m? M is this guy, isn't it? Right? M is just that guy. So is 3x squared y minus 6x. Right? So first, what would you do? First, integrate. Second, differentiate. Third, compare. Right? First, integrate. So I'm going to integrate this by x. So I have f equals mxy dx plus gy. Okay? The integration of df by dx, we have f, right? The integrate of the of the derivative is f, right? And then we integrate m by x. We have a constant term, but the constant term is in terms of y. Don't forget, we are in the partial derivative and partial integration world. Okay, so right now I'm gonna integrate m, which is 3x squared y minus 6x dx plus gy. And this guy is, you integrate by x, right? So y is a constant. So that will be x cubed y. That's it. Will be x cubed y minus 3x squared plus gy. Why? Because if you look at this guy, integrate of 3x squared y dx, integrate of x squared is x cubed divided by 3, right? These and these are just constants, right? So 3 cancel out. So you have x cubed y. Make sense? And this one is x squared divided by 2. And 2 here and 6 here becomes 3. Make sense? So right now, don't forget the solution is f equals c, right? The solution is f equals c. So f here, we already know f, but we have gy here as well. So we want to get rid of gy, right? We want to know what gy is. So what we do is what? Differentiate, right? We integrate, differentiate, and we compare, right? So then we differentiate f by y. So we have that this guy is x cubed minus 0, right? Plus g prime y. Make sense? Because if you do the partial derivative by y, so x are constants, right? So here is just x cubed, and here is 0. Make sense? But because we know that is a exact equation, so we know that nxy is df by dy, right? But nxy is what? Nxy is x cubed plus 2y, isn't it? So what we have is x cubed plus 2y equals x cubed plus g prime y. So these cancel out. So we have that g prime y is 2y, which means that dy is the integration of 2y dy, right? Which is y squared. So right now we know that fx y is x cubed y minus 3x squared plus y squared. So the solution is x cubed y minus 3x squared plus y squared equals 0. That's it. And that is the solution. Oops, sorry, not 0. C equals C. The solution is f equals C. Don't forget, guys. F equals C. That's the solution. So here I have solved this problem by considering df by dx equals m first. But I told you guys that you can do it differently by starting with df by dy equals n, right? And I'm gonna show you that it works as well. So I'm gonna look at the same example, but for this one I'm gonna start with dn by dy equals x cubed plus 2y. Okay, I'm gonna start with this. So if I start with this, first I need to integrate, differentiate, and compare, right? But if I start with dn by dy, I'm gonna begin with oops, sorry, my bad, sorry. That's not what I should have started. Is df by dy equals n xy, right? Which is, sorry, right? And then I integrate. So I have that f equals integrate x cubed plus 2y dy plus h of x, right? Because you have the derivative by y, so you integrate by y, and you get the constant term, which is in terms of x. Makes sense? And then you find the integration is x cubed y plus y squared plus hx. And the solution is f equals c, right? So we want to know h. So we differentiate. We differentiate f by x. So we have 3x squared y plus 0 plus h prime x. And then we compare this because we know that is an exact equation, right? Which means that df by dx also equals m of x, y, which is 3x, xy minus 2 dx. Okay? Oops, sorry, there's no d. Okay? So, we have that 3x squared y plus h prime x equals 3x xy minus 2. So it's 3x squared y minus 6x, isn't it? Okay, so these are cancelled out. So we have that h prime x is actually minus 6x. So hx is integrate of minus 6x dx, which is minus x squared 3x squared. Makes sense? So the solution is f xy, which is x cubed y plus y squared minus 3x squared equals c. That's it. That's the solution. And you can see they are the same. They are exactly the same thing. Right? So it doesn't matter. You can begin with, df by dx equals m, and then integrate by x, differentiate by y, and compare. Or you can begin with df by dy equals n, then integrate by y, differentiate by x, and then compare. You have the same solution. Okay, this is direct method. But guys, note, if I were you guys, even if I said that they give you the same solutions, but just take note that I'll begin with df by dx equal m if this guy is easy to integrate. Don't forget, we need to integrate first, right? And then differentiate. So if you begin with, the function that you can integrate pretty easily, your life is going to be much easier. And similarly, I'll begin with df by dy, which is equals n. If this is easier to integrate, right? So basically, you look which one is easier to integrate. Okay, this is integrate with respect to x though, and this with respect to y. Okay, you see which one is easier to do the integration, and you pick that one. Make sense? Make sense? But after all, it doesn't matter which one you choose, you get the same results. But it's just that if you choose it, wisely, life is gonna be easier. Okay? So let's look at this example. This is a good example of choosing where to start. Okay, we have two places to start. First, we can begin with df by dx equal m, or df by dy equals n. Right? But if we begin with this, f is going to be integrate of m dx. And if we begin with this, f will be integrate of n dy. Right? And which one is easier? Pause now. Not now. Listen to me. Okay, listen to me until it ends. Just look at it yourself and answer yourself which one is easier to integrate, and then pause. Okay, when you get the answer, come back and watch it again. Okay, I want you guys to think as well, not just to listen to what I'm saying. Okay, so just pause here, think yourself, which one is easier to integrate, and then you come back and see. Okay. Okay, welcome back. Okay, I know that many of you paused it, but many of you didn't. It's up to you, right? But it's a good way of practicing thinking. And if you look here, integrate of mdx, you need to integrate this guy dx, right? You need to integrate this guy dx. This is easy. This is easy to integrate by x. This is easy as well, and this is easy. But this guy it's not hard, but it's not so easy. Because if you want to integrate x e to the x y squared dx, this guy you need to do integration by parts, right? Remember, x e to the x. If you want to integrate this, you need to do integration by parts. Okay? See? But here, if you begin with this, you integrate this guy by y. So you have 1y here. This constant, easy. Right? Right? No y here. Easy to integrate. Y cubed, easy to integrate. So if I were you, I would begin with this choice. Okay? But you can try begin with this choice as well. I have already done that and obtained the same result. Okay? If you do things correctly, it doesn't matter which one you begin with, you get the same result. It's just that this one is a little bit harder because you need to do integration by parts. Okay? Okay? Cool. So I'll begin with, so let's begin. I'll begin with f equals df by dy equals n, which is minus 2xy e to the x plus psi x minus y cubed. Okay guys, I just push the minus sign in the parentheses. Okay. Okay. So let me know if I do anything wrong. Okay, just text me afterward. I'll fix them. Okay, so what's next? I need to integrate, right, this guy by y. So I have that f is integrate of this guy dy plus h of x. Don't forget guys, if you integrate dy, the constant is in terms of h. Okay, so I'll just integrate it. This is minus 2x e to the x, and integrate y is y squared divided by 2. So this cancel out. Make sense? Integrate of psi x is just a constant. Don't forget. So it's just plus psi x and then y. Right? Psi x is just number. We don't care. Right? We integrate by y. Minus y to the power of 4 divided by 4 plus h of x. Make sense? So we have that f is actually minus x e to the x y squared plus y psi x minus y the power of 4 divided by 4 plus hx. And then we integrate. After that we differentiate, right? We differentiate. So how to do that? We just differentiate by x. So we have that df by the x is, what is it? Is minus y squared, and then I'm gonna differentiate this guy, which is f and g. So I differentiate f and g, which is f dg plus g df, right? So it is f, which is x, e to the x plus e to the x by dx is just 1. Plus y, the derivative of psi is, oops, sorry, I differentiate by x. So y, the derivative of psi is cos x, and derivative of minus y to the power of 4 divided by 4 is 0, because they differentiate by x. So y is a constant, so it is 0. Plus h prime x, and this is minus y squared x e to the x minus y squared e to the x plus y cos x plus h prime x. Right? But we know that df by dx is actually mxy, right? But mxy is actually this guy, isn't it? So we compare this with that. Okay. So we have that minus x y squared e to the x, this one are cancel out. Y cos y cancel out as well. Sorry, y cos x cancel out as well. Minus y squared e to the x cancel out. So if you compare this df by dx with this df by dx, which is m, which is this guy, we have that these, three terms are cancel out. So we have that h prime x is actually 2x cubed, right? Which means that hx is integrate of 2x cubed dx, which is x divided by 4, which is 1/2 of x to the power of 4, right? So right now we know that, don't forget, our solution is fxy equals 0. That is our solution, fxy equals 0. Oh, sorry, not 0, equals c, my bad, sorry. So the solution is fxy is minus x e to the x y squared. Don't forget, guys, fxy is here, right? Plus y psi x minus y to the power of 4 divided by 4, and then plus x to the power of 4 divided by 2, which is hx here, equals c. And that is the solution. Make sense? Does it make sense? Okay. Okay, guys. Let's look at this example. First, we need to check whether or not this equation is an exact equation. In the previous question, I didn't check it because we have checked it in the previous slide, right? So I didn't check it again, okay? But here, we haven't checked it yet. So we first need to check it, whether or not this equation star is an exact equation before we proceed, okay? So first I'll check. So I'll look at dm by dx. So, sorry, dm by dy. So we first need to differentiate this m by y, right? And that is equal to, here is f and g, right? This is one function, this is another function. So you need to differentiate fg, the multiplication of functions. So you get f dg plus g df, right? So what you have here is y, derivative of cos is minus sine. xy, and by chain rule you have x here plus cos xy dy by dx is just 1. Okay, so the next one is what is 6x squared y. Derivative of minus 2x by y is 0, and derivative of minus y is minus 1. And then we find the n by dx, and that is similarly we have x and cos xy, so we need to use the derivative of fg, which is f dg plus g df. So f x dg, which is derivative of cos, is minus sine xy, and by chain rule we have y here, plus g, which is cos xy, dx by dx is 1, plus 6 x squared y minus 1. So you can see that they are equal, right? Which means that the equation star is an exact equation. Okay, it's an exact equation. So what happens if it's an exact equation? We have two choices, right? We can begin with df by dx equals m, or df by dy equals n. It depends on which one is easier to integrate, right? But as you can see, you can begin with df by dx equal m, or df by dy equals n. So if you begin with df by dx equal m, it means that you need to integrate this function by x, right? Integrate this function by f, and that's not a big problem. It's not a big problem. Why? You might look here. Is this a problem? No, because it's y and y. They are just constants. It will be hard if we need to integrate this function by y. Make sense? But if you want to integrate by x, it's not that hard, right? Because it's just x. And similarly, if we want to begin with this, we need to integrate this function by y. And that's not hard as well. So for this problem, is pretty much the same. You know which one you want to begin with. Okay, so I'll begin with this guy. df by dx equals m. So what I have is f equals integrate of y cos xy plus 3x squared y squared minus 2x minus y dx plus gy. Okay, makes sense. And then I'm gonna integrate this function by y. By x. So what I have here is, guys, how about I split integration? Guys, if you are an expert in this, integration, you can just do it quickly. But I'm afraid that some of you might not understand, so I'm gonna do it slowly. So basically, I split the integration, right, for each term. Sense? And then this integration is what? If we want to integrate this, we need to do integrate by substitution, right? Integrate by substitution, which is integrate of y cos xy dxy, and then you look at this xy as u, right? But guys, dxy is actually what is y dx. Guys, it's not x dy plus y dx, because in this case we look at y as a constant, okay? So we can pull it out. It's like d of 2x is 2dx. So what I mean? In this case, y is just a constant. Okay? Right now, when we do partial integration, y is seen as a constant. But guys, dxy is y dx. Right? So we need to push this y in there. Right? So this y dx becomes dxy. Make sense? Make sense? So we don't have y here anymore. Ooh. Plus this guy is integrated by x is x cubed y squared minus x squared minus xy plus gy. Okay? And then I integrate this guy. The integration, of course, is sine, right? It's sine xy plus x cubed y squared minus x squared minus xy plus dy. Okay, so we are done with the integration, right? So next, what we need to do is differentiate. We need to differentiate by y. Okay, so let me get to the next page. No space left, so I'll get to next page. I'll just here, and this is f, right? So I take the derivative of f by y. So what I have is cos xy, and from chain rule I have x here, plus 2x cubed y minus 0 minus x plus g prime y. Okay, and then because it's an exact equation, isn't it? So we know that df by dy also equals n of xy. But what is n of xy? Is this guy, isn't it? I'll just copy it. Oops. And I'll just paste it here. Make sense? So they are equal. So I'm gonna compare, okay? So these cancel out. I use some other color. These cancel out. These cancel out. These cancel out. It means that g prime y is actually 0. It's actually 0. Okay? Which means that gy is just a constant, right? You integrate 0, you get just a constant. So we have the solution, which is f xy equals constant. Okay, I'll just call it c star, constant c star. And we have the solution f xy equals constant, right? Which is sine xy plus x cubed y squared minus x squared minus xy plus c star equals c. Okay, guys, but because c star here is just a constant, isn't it? So I'll just put it here, subtract c star. Thanks. So the solution is sine xy plus x cubed y squared minus x squared minus xy equals c. I can call it c0 if I want, when c0 is c minus c star. But as I told you guys, they are just constants, okay? So you can just call it c if you want, okay? And that is the solution. Make sense? So just to sum it up, to this point, we know how to solve the exact equation using the direct method, right? We have two choices depending on which one is easier to integrate, right? So we have two methods, two choices, but we haven't seen the observation method yet. Okay, so now we're gonna look at the observation method. Let's first consider this equation. When this equation is an exact equation, we have that there's a function f such that what df by dx is df by dx is m x y and df by dy is n x y. So in that case, we have that this is m, right? This guy equals 0, or this is 0. So this is actually what we had in the previous method, the direct method, right? And just to remind you what it is. And then let's consider this equation. Can we use differential formulas to write a as this? If yes, the solution is f equals 0. So what is differential formula? Differential formula is when du plus or minus v is du plus or minus dv. duv is u dv plus v du, and du divided by v is v du minus u dv divided by v squared, right? We know these formulas, right? The formula from differentials. Okay, makes sense. So I'm gonna show you, if we have an equation like this. In the previous section, we looked at it. We looked at this guy as df by dx, right? And then we integrate, we differentiate, and then we compare. Or we look at this guy, we integrate, we differentiate, and we compare, and we get f, right? Sorry, it's a typo here. It's not f equals 0, it's f equals c, and that's the solution. Okay, but if we don't want to do that, so what else can we do? Let's look at this one. This is the one we did before, right? This is the one we did before. Instead of doing integrate, differentiate, and then compare, it's such a long process. So if you are really good, you can do it like this: 3x squared y dx minus 6x dx plus x cubed dy plus 2y dy equals 0. Okay. And then I group this guy together. 3x squared y dy plus x cubed dy plus 2y dy minus 6x dx equals 0. And guys, if you observe this part, which is from here and here, right? Right. This guy is actually d of x cubed y. Make sense? Why? Because d of x cubed y is x cubed dy plus y 3x squared dx. Make sense? Make sense? Or if I go even slower, it will be y dx cubed, which is x cubed dy plus y. Dx cubed is 2x squared dx. Right? 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 And d of y squared is actually 2y dy. So these are, formulas from, when you studied differentials in calculus. Okay, and similarly, d of minus x squared is minus 2x, right? Oops, sorry, I should have had 3 here. So it would be minus 6x dx. So in that case, we have that this guys is actually d of x cubed y plus dy squared plus d of minus 3x squared equals 0. Which means that this is d of x cubed y plus y squared minus 3x squared equals 0. Which means that, guys, this is actually fxy. So the solution is x cubed y plus y squared minus 3x squared equals c, and that is the solution. And if you compare, it's exactly the same solution as what we had before here. See, same solution. Okay, this one is called observation method. Guys, I know it looks easy, but it's really hard. It's actually hard because it's not easy to see, which it is not easy to look at this in this form. But this question is not that hard because, the equation is pretty simple. But if the equation is complicated, it's going to be really hard. So avoid using this method unless you are really good at it. Okay, you can try practicing it, okay, and you can try using it. But in the exam, if you are not sure, avoid using it. Okay, it's an alternative method. It's quicker than the direct method, but it's a bit tricky. It requires, you should it requires that you can look at, this guy and be able to convert it into this form, right? But the direct method is longer, but it's straightforward, right? Integrate, differentiate, compare. That's straightforward. Okay, so let's look at another example. This one is the one we did as well. This one is a lot harder to see, to use the observation method. Why? Because I'll show you. Here, if I write it like this, 2x cubed dx, right, from this guy, nothing. nothing complicated. Then minus y squared x e to the x plus e to the x dx plus 2xy e to the x dy. Is that okay? That's okay. Because here we have this guy, right? This guy, right? I just pull y squared out. Okay? Okay? So, it's this. And we have the minus signs here. Okay? Similarly, here, x e to the x, y squared is from this. Okay, I pull y squared out. Okay, and we get dx. Okay? And for the next one, 2xy e to the x dy is from this. Make sense? Thanks. And the minus sign here, actually here. Cool. Cool. And then I have that is plus y cos x dx plus sin x dy. Where is this from? I'm gonna use some other colors, like this color. Y cos x dx, this guy. See, and sin x is from here. Okay, you have no minus because it's minus minus, actually plus here. Makes sense? Makes sense. And then the last one, the last part is minus y cubed dy equals 0. Minus y cubed is actually from this minus y cubed. You have minus because you have minus in the parentheses. Get the minus. Okay, okay. And then this guy is actually, I'm looking how should I do it to be easier. Can I do it like this? Maybe it's easier to understand. I just put it between the line, and then I use some other colors. Okay, so you know that this guy is actually the x the x to the power of 4 and half of the x to the power of 4. Make sense? Because half of the x to the power of 4 is actually half of 4x to the power of 3, and that is 2x cubed dx. Make sense? Make sense? Sense? Okay. And then if you look at this guy, it's actually dx e to the x. Did you remember? D of x e to the x is d of fg, right? So it's x e to the x dx plus e to the x dx. Make sense? Make sense? Okay. Okay. And then what else? The next term is this term is actually 2. It's actually x e to the x dy squared. Make sense? X e to the x dy squared. Because it's x here, e to the x here, but dy squared is 2y dy. So we have 2y dy. Okay? And the next one, this guy is Okay, can I go a little slower? It will be y d psi x, because y d psi x is y cos x dx, right? Right. And this is sine x dy. I didn't change anything, but keep it there. And this is clearly, this is minus d of y to the power of 4, and you have 1 divided by 4. Okay, so I'm gonna rewrite this guy. So what I have is half of dx to the power of 4 minus y squared dx e to the x dx e to the x plus x e to the x dy squared, right? This is this, this is this, this is this. Okay, I know this is confusing and this is really complicated, and I won't recommend you to do this in the exam, but it's quite hard. I think it's easier to use the direct approach, integrate, differentiate, and compare. Okay, so next it will be plus y d psi x plus psi x dy minus 1/4 of dy to the power of 4 equals 0. Okay, and then after that we get that is half of dx to the power of 4 minus this guy is actually d of x e to the x and y squared. See why? Because it's f and g, right? So it's f dg plus g df. Make sense? Make sense? Then you have this guy is d of what? D of y psi x. Why? Because you have f and g, so which is f dg plus g df. Make sense? Make sense? And then you have minus half of 1/4 of dy equals 0. So what you have is d of half of x to the power of 4 minus x e to the x y squared plus y psi x minus 1/4 of y to the power of 4 equals 0. Which means that this guy is actually f. Make sense? Make sense? This guy is actually f. Okay? And that is the solution. So can I write here? So the solution is half of x to the power of 4x e to the x y squared plus y psi x minus 1/4 of y to the power of 4 equals c. Okay? Guys, for this problem, actually I should have checked whether or not this equation is an exact equation, but we have checked it in the previous example, which is where is it? Which is this one. We have checked it already in the previous slide, right? Right? And this is the solution. And you can see is exactly the same as the one we obtained by observation method. Okay? So the observation method can be a lot shorter, But for me, from my point of view, I think it's harder, right? It's tricky. You need to be able to see that, you need to group this, and then you need to group this, and then you need to group this, and then you get this, and then you group it like this. You never know. Okay, it's hard to see. It's hard to see it through unless you are really, really good at it. So that requires lots of practicing. Okay, so if I were you guys, I would stick with the direct method, but it would be great to be able to do both methods. Okay, but I'm just telling you that this approach is a lot harder. Okay, that's it. So that's the end of the exact equation. How was it? I know it can be hard, right? This one, but if you follow the step, right, for the direct method, integrate, differentiate, and then compare, right, and you get the solution is f equals c, and that is the solution, right? So let me sum it up. Today we looked at the what is it, exact equations. Sorry, I just forgot the name. Exact equations. And the exact equations are equations that you can find f, right, called potential function, such that the f by the x is m and the f by the y is n, right? And we have a theorem saying that if the m by the y equals the n by the x, we can say that the equation is an exact equation, right? So once we know that it is an exact equation, we have two approaches, the direct method and the observation method. Okay, I'm not going to talk about the observation method. Okay, I'm going to focus on the direct method. So for the direct method, we have two choices. The first choice is to begin with the f by the x equals m, right? And then we integrate with respect to x, and then we differentiate with respect to y, right? And then we get the function gy, right? After that, we know that the solution is f equals c. For the other choice, we begin with the f by the y equals n, right? And then we integrate with respect to y, right? And then we have hx, which is a constant, but it's in terms of x because we integrate with respect to y, and it's partial integration. After that, we differentiate with respect to x, right? And then we compare that with the f by the x, which is m. Okay, and then we get hx. After that, we get the function f. Then the solution is f equals c. Okay. The observation method is just to use the formulas from differentials in calculus, in calculus 1, and then we try to find the f equals 0 using those formulas. Okay, and the solution is the same, f equals c. Make sense? And in the next section, we're gonna talk about equations which are not exact equations. Okay, we're gonna talk about ODEs which are not exact equations. There is a thing, we call it integrating factor, that we multiply to that function and makes it exact equations. So guys, you need to focus on this method as well, because we're going to use it in the next video as well. Okay, Okay, so try to understand the method. If you have any questions, any problems, just contact me, okay? And we can talk about that. Okay, so bye for now. Okay, take care.